Hello, my dear student friends. In the last video lecture, already I have started the discussion about the conservation laws. In that video lecture, already I have given the definition of generalized definition of conservation of law, and also I have discussed about the law of conservation of energy. That definition: energy neither be created nor be destroyed; it can transfer from one form to the another form, right? And so it has some limitations. It means it fails to provide the proper results. So that's why we need required to use another conservation laws, that is law of conservation of linear momentum, law of conservation of angular momentum, right? So in the last class I have already told about the linear momentum. What is the linear momentum? Means in the motion there are the two types of motion. One is a linear motion, another one is a rotational motion. Okay, the linear motion usually have the linear momentum and rotational motion have the angular momentum. And linear momentum means what? It is the, mathematically we have to say it as it is the product of mass and into velocity. It is the product of mass into velocity. That is, we are going to denote it as a P. That is, P is equal to mv, and the SI unit of linear momentum is kg meter per second, right? And the dimensional formula m l t to the power of minus 1. That is the dimensional formula of linear momentum. With the example I have already explained in the last video lecture. Those who have not seen the video, just go to the last link video, that is conservation of law 1.0. okay, right. Now in the today's video lecture I am going to discuss about the law of conservation of linear momentum, right? So what it means, law of conservation of linear momentum? Initially I have told linear momentum, it is the mathematically a product of mass into velocity. That is a linear momentum. Then conservation of law of conservation of linear momentum means, we can say it as in generally the linear momentum neither be created nor be destroyed. Is it? You can say in the same manner which we have said in the energy, of course, but in a precisely we are going to define in a specific way. It states that the total linear momentum of a system of particles, the total linear momentum of system of particles free from action of external force and subjected to only the mutual interaction between them, that is remains constant no matter how the complicated forces are, right? That is the definition of law of conservation of linear momentum. Here consider a system of particles. The system of particles consists of a n number of particles. Okay, so individual particle have the linear momentum, right? So if there is no external force on that body, then no external force on that body means the external force is 0. Okay, but there is a mutual interaction between those particles. Okay, that mutual interaction is remains constant, means individual particle have the linear momentum, so that mutual interaction is remains constant means that linear momentum of individual particle is remains constant. That is nothing but we have to say it as a conserve, or no matter how the complicated forces are, whatever it may be the forces, but linear momentum is conserved. So let us see once again. It states that law of conservation of linear momentum, it states that the total linear momentum of system of particles free from action of external force and subjected to only the mutual interaction between them remains constant no matter how the complicated forces are, right? Now I am going to explain in a mathematical way. Mathematically, I hope you already studied the Newton's 3 laws: Newton's first law, second law, third law. Here I am going to consider the Newton's second law, right? Means according to the Newton's second law, in the different way of the definition, that is the force acting on the body, that is equal to the rate of change of linear momentum with respect to time. Right? That is a rate of change of linear momentum with respect to time, that is nothing but a force. So F is equal to dp divided by dt. I hope already I told you that is P is nothing but mv. Right? So if I differentiate this term dp divided by dt, it is nothing but, here I am going to write d mv divided by dt. Here mass is a constant and velocity is a variable term with respect to time, but mass does not vary with respect to time. So here I am going to write m is a constant term, so only I am going to differentiate dv divided by dt. dv divided by dt is what? The rate of change of velocity. It is nothing but an acceleration. I hope now you got, that is F is equal to ma. I hope you know that this formula oftenly used in the physics, that is F is equal to ma. Now here we have considered, that is F is equal to dp divided by dt. Here F is nothing but an external applied force action on the system. Here I have considered a system, there is an external force on that system, that is F, that is equal to dp divided by dt. Now if the external force acting on the system is 0, right? Here there is a system, okay, on that system the external force acting on that body is 0. So if external force is 0, then automatically F is 0, right? If F is 0, then dp divided by dt, here F is equal to dp divided by dt, right? And now here F is 0 means dp divided by dt is equal to 0, right? Okay, the differentiation of some constant term is nothing but a 0. In a differentiation you have already studied that the differentiation of any constant term is 0. So similarly here, if this is a differentiation of dp divided by dt becomes 0, it means what? It means P is constant, that is linear momentum is constant. So P is equal to constant, right? Now the total linear momentum of system of the total linear momentum of a system, that is remains constant. Okay, the total linear momentum of a system of particles is remains constant, right? Here there is no external force acting on that body, right? Okay, let us see an example for law of conservation of linear momentum. If a bullet fired from the gun, okay, that bullet will move in the forward direction and gun will move in the backward direction. Okay, according to the Newton's third law, every action has an equivalent opposite action and reaction, right? So here bullet has a mass m and it is moving in the forward direction with the velocity v, and gun, it has a mass, that is I am going to represent it as a capital M, and it is moving in the backward direction with the velocity capital V, right? Now the momentum of the bullet in the forward direction, the momentum of the bullet in the forward direction, that is mv, right? And now momentum of the gun in the backward direction, that is it is moving in the backward direction, so I am going to take it as a negative sign, minus capital M, that is the mass of the gun, and capital V, that is the velocity of the gun, means it kicks back in the backward direction. So now here the bullet is moving in the forward direction and gun is moving in the backward direction. According to the Newton's third law, every action has an equivalent opposite reaction. Okay, action and reaction. So now I am going to take the momentum in the forward direction, that is mv is equal to the momentum in the backward direction, that is same. capital M V. Here negative sign indicates what? Means the momentum is negative? No. Means here this gun is moving in the backward direction and this bullet is moving in the forward direction. The negative sign implies that only. So now I am going to take MV is MV plus, I am going to take minus MV on this side and plus MV, that becomes 0. So what it implies is, that is MV is nothing but a P. I am going to take it as a small p, and this MV is nothing but, let us see, this is a P1 and P2. Okay, this is a momentum of the gun and this is a momentum of the, this is a momentum of the bullet and this is the momentum of the gun. Right? Now this is becomes 0. Means the total linear momentum of the body is remains constant. So that's why it is becomes a 0. Right? What it means remains constant or that is a conserved? Okay, before firing the bullet, that linear moment is constant, that is 0. After firing the bullet, the linear momentum again it is 0. So what it means, the total linear momentum of the system of body is remains constant, or we can say it as the linear momentum of the system is conserved. This is an example for law of conservation of linear momentum. Okay.